Okay, so we are going to see like what is big data, and in that what is PySpark. So first we are going to talk about all the details about big data. What is big data? Then we are going to see about the big data ecosystem. Like we're going to talk about what is Hadoop, and after that we are going to talk about Spark. So when it comes to big data, if I ask you the definition of big data, like anyone can say that big data, if my data is very big or if my data is very large, I can call it as a big data, very large data. Yeah, I can say that that is also correct if your data is large. And someone says that if the data with respect to volume is very much and that doesn't fit in my single machine, it doesn't fit in my machine, you can call that, okay, that can be your big data. So here everyone's definition is correct. Like if your data is very big, if your data is in big in size, big in volume, and if it doesn't sit in a traditional machine like a single machine, that can all considered as a big data. But what IBM has done, IBM has put a definition of big data like three V's. Later on, they have moved it to four V's, but they have defined it by three V's. So let us see what is big data, the correct definition. So big data is that data that contains greater variety. So now what do you mean by variety? We are going to see in detail about variety in coming slides. So now the data is not only in a table format. If you see the data is not generating in table format now. The data is in various formats. It is in a structured format, it is in a semi-structured format, it is in a unstructured format. Suppose if I like to give you some examples, if you look about the variety, so your data generating can be, if you talk about social media, it can be in the term of likes, it can be in the term of comments, it can be in the form of images, and so on. You can see there are so many different wide varieties. It can be in the form of reels, it can be in the form of videos. There are so many different formats or different varieties the data is getting generated. And when it comes to, this is first V, that is variety. When it comes to second V, that is volume. So if you think on volume, the data generating 10-15 years back, I mean in 2005 2010, the data generating was very less when you are comparing to 2021-22. So here the data generation has grown exponentially in terms of volume. I have some statistics in the next slide. I'll talk about that. Then this is our second V. Third V is velocity. Now just imagine that you have one IoT or if you have one sensor that is generating the data continuously. So 24 into 7. So just imagine how much speed or how much velocity the data is generating or how much uh, like in just think on the speed how the data is generating. So these are like three different V's. If we have three different V's in your data, we call that data as a big data. So let me show you some of the statistics here. Suppose if you just take an example of YouTube, only YouTube, not any other platform. So there every hour there is 30 hours of videos are uploading. Can imagine for 30, every hour 30 hours of videos are uploading in YouTube. So if you just calculate how much like speed is there in every hour, and you can see the variety also, that can be different varieties of videos. And you can see that if each video is of 1 GB, if it is of 500 MB, and you can just imagine 30 hours of videos are uploading every hour. When it comes to The New York Stock Exchange, that is one of the biggest example of big data generating. So it generates almost 1 terabyte of data, 1 terabyte of data per day. You can imagine, per day. I have written it per day. And when it comes to social media, social media, the statistic shows around 500 500 plus terabytes of data is generating, or it is ingesting into databases from the social media sites like Facebook, Twitter, LinkedIn, and all every day. So just imagine, oh my God, more than 500 plus terabytes. We are not talking about MBs and GBs. We are talking about terabytes of data generating every day. Then let me take a next example, that is jet engine. So if you are taking an example of jet engine, if your jet engine is running, a single jet engine is running for continuously for 30 minutes, okay, I'll tell you about 30 minutes flight time, it will generate around 10 plus terabytes of data. So there are so many sensors attached to the flights, like it is checking your temperature, it is checking your pressure. I mean, temperature and pressure outside the flight, inside the flight, and there are so many sensors at the wings, so many sensors at the like fuel tank. There are so many hundreds of sensors are attached, and you can imagine all the sensors are generating the huge amount of data. So for 30 minutes of flight, you are generating 10 plus terabytes of data. And just imagine if your flight time is more than 10 hours, more than 12 hours, then you will like end up getting your data in petabytes. So we are talking in petabytes also. So this is how the data is big. So with this definition, I hope you got some understanding, like the generating of the volume, the variety, and the velocity of the data is huge than never before, and it is increasing every day. And there is some statistics. So 2.5 quintillions, that is 2.5 into 10 raised to 18 bytes of data has been created every day. If you consider in all scenarios, like in all the examples, 2.5 into 10 raised to 18 bytes of data is created every day. So I got one image from IBM itself. This is an IBM image. I'll give you a link of this. Uh, what they have defined later on, they have introduced fourth V also. So first they have introduced like volume, velocity, variety, and the fourth V they have introduced is veracity. So let us talk some statistics based on this. So first V, as we have talked, that is volume. So some statistics, if you compare the volume of data increasing from 2005 to 2020, so there is almost 300% or 300 times your data has been increased in terms of volume. Now there is almost 40 zettabytes of data generating in terms of volume. And they have given a simple statistics, like if you look at the world's population, that is around 7 billion. So out of 7 billion, 6 billion people have their cell phones. So now you can imagine how much data it is generating from that phones. We are not talking about smartphones, we are just talking about phones. And when it comes to second V, that is volume. So, sorry, second V, when it comes to velocity. Recently, I've read an article that General Electric GE have developing a modern efficient engine for the car, and they are placing more than 100 sensors on that engine. You can just imagine 100 sensors for a car engine. So just imagine if that car is running continuously for testing that engine, it will run maybe for like hours, days, and weeks also to for testing. And you can imagine how much data they are generating from this engine. And that when you talk about sensors, continuously the data is flowing, continuously the data is streaming. So that is the velocity. You can read the more statistics here. Then very important, third, that is variety of data. That is like different forms of data. Now, if you go back 10, 15 years down the line in 2005, 2001, 2, something like that, there the data generating was mostly in a table format. Like we were generating a table, but now the data generating is not only in table, there are varieties of format. You can see some images here. So your data generating from a smartwatch, we were not imagined 15 years, 20 years back that data can be generated from a watch, and the data generating from videos. So 4 billion plus hours of videos are watched on YouTube each month. You can imagine. And there are 400 million tweets are sent per day, and about 200 million tweets are shared monthly with the active users. And you can see the varieties of data. Now the data is generating from the sensors, data is generating from the smartwatch, obviously from the smartphone, smart TV, and from the tweets, from the images, from the videos, from social media, and so on, so on, so on. So the variety has been widely increased now. So that is where we are talking about the importance of big data, importance of data engineering. uh, we basically like create a pipeline where we convert your raw data, your unstructured, semi-structured data to a structured data. That is a basic understanding of big data and data engineering. Then when it comes to veracity of data, so their veracity is nothing but that uncertainty of data. Suppose whatever data is generating in different format with a huge amount of volume, and it is coming continuously, it has huge speed with them like velocity. But out of all that data, you cannot use that data directly for your business purpose. You cannot directly put that into an action. Suppose I have like used data, and if I say that, if I ask some questions to that data, like how much was my sale, like which product got me the highest profit, what was the product which made me loss, and what was my last year sale, what was my last week sale, can I answer all that business questions? No, you cannot, because your data is in raw format. So when it comes to veracity, it says that according to one survey, 27% of your data, like out of 100%, 27% of your data is only respondent. Like other 73 to 74% of data is not, you cannot answer the business questions from that. So when it comes to veracity, it means that quality of data is not good. So we have to increase the quality. Like your data should be ready for the business use. That is what veracity is. And they have introduced the fifth V also. That fifth V comes to value, I guess. Okay. So these are basic uh, understanding of big data and their V's. Let us move forward. Like I would like to show you one more slide. Like that, just see like the statistics, like what happens every 60 seconds online. That is like in every minute you can see so much is happening around the internet with only few. I have taken only few of the images. So you can see there are almost 1300 plus LinkedIn posts every 60 seconds. And you'll be surprised to know the number here in Instagram. You can see that 65 or more than approximately 66,000 Instagram pictures have been uploaded every 60 seconds. And 500 hours of videos are uploading in YouTube. 3 lakhs plus tweets, 3,50,000 plus Snapchat stories. And if you look at the TikTok views, Pinterest pins, and Facebook likes. So this is what the big data world is now. So from this, yeah. So with this huge data, we are going to see like what are the forms of big data actually. So just now we have discussed like there are in basic or broadly categorized into three different forms. One is structured data, one is semi-structured data, and the third is unstructured data. So let me show you the example. When it comes to the structured data, when you have uh, like a highly organized data. For example, if you look at the table, if you look at any Excel sheet, or if you look at the CSV file, no, we'll talk about CSV file later on, or if you look at the database or RDBMS, any table inside the relational database, which has high degree of organization, high degree of organization. So what do you mean by high degree of organization? So you can consider like a table which has rows and columns, which has rows and columns in your data. So that can be a structured table, structured data. So whenever you have row and column in your data, it is called as a highly organized or high degree of organization, and that is called as a structured data. Some examples of structured data are your Excel file or your Excel spreadsheet. Obviously, it has some columns, it has some rows, it is a structured data. Second, your CSV file. So now you can call CSV file as a structured or as a semi-structured depending upon your how the data is. Then the third is your relational database tables. Okay, these are considered as a structured data. When it comes to semi-structured data, so it has some degree of organization, some degree. So when it compared to high degree of organization, it has some degree, so it is not in the form of table most of the time. So some of the examples are like your HTML files, your JSON files, your XML files. I will show you like some files how your semi-structured data exactly looks like. When it comes to unstructured data, so here when you are talking about the degree of organization, there is actually no predefined degree of organization, no predefined degree of organization. So there is no specific format for the unstructured data, no format, no specific format. Okay, so it can be images, it can be audios, videos, your plain text files, your word files, your PDF files, or whatever I'm writing now, whatever I'm writing on this screen or writing on a piece of paper, that can be considered as a unstructured data. And if you consider a doctor who is writing a prescription, if he write the prescription like this RX and starts his prescription, that can be considered as a raw data only, that can be considered as unstructured data only, because this is someone who is writing, there is no order actually, there is no in the form of table. So that all examples can be considered as a unstructured data. So now if I give you like an example of what is your uh, ML, what is AI, and what is big data, in that what they are doing, how they collect this data. I will talk everything about that. But before that, let me just show you how exactly your structured, semi-structured, and unstructured data looks like. I hope unstructured, everyone are familiar with the unstructured data. If you have any images, any audio files, video files, so you can take in videos of YouTube, you can take audio files of any Alexas or Siri's. These all are considered as a unstructured data. Okay, so let me, yeah. So this can be considered as an Excel sheet. So this is obviously in it has some columns, it has some rows. So you can see this is considered as a structured data. So when you look at the definition of structured data, it has high degree of organization. So we can answer some business questions out of this. Suppose if you ask me like what was the highest sale, I can apply some filter. I can, if you ask me like what is my total sales uh, what is the total sales amount, I can easily do that. I can do like this, and you can find out the sum here. I can find out what is the count and what is the average sale. And there are, you can see more than 9,995 rows are there, but still I can do working on Excel. I can do that. If you ask me like what was the quantity sold on this, yeah, these are the quantities sold in how many years. You can answer all these questions easily. So if you have a structured data, you can answer your business question. That is one thing. But if you want to like go in advance, you cannot do that in Excel. So we have to connect this Excel sheet to any of your BI tool. That can be your Power BI, Tableau, and so on, to pull out some key information, to pull out some actionable information from this. Okay, so now let me show you the example of semi-structured data. Yeah, so this is a raw file. Actually, the data is of all Formula One racing. So if I show you, suppose CSV file. So now this can be considered in both the ways, like a structured also, semi-structured also, because you can see that you can easily read, okay, this is having a first column circuit ID, second column circuit reference, name, location, country, latitude, longitude, altitude, and URL. So these may be your column names, and this can be your first record. You can see for name, sorry, circuit ID, circuit reference, name, country, Melbourne, and location Melbourne, country Australia. This is your latitude, longitude. This is your last URL. First record, second row, third row, and so on, and so on. So it can be considered a semi-structured or a structured depending on the data. But when I open a JSON file, here you can see in a JSON file, this is purely a semi-structured data. So you can see you have a like a dictionary here. It is showing you the values like key value, key value, key value, key value pair. And this is your first record. This constructor ID, constructor reference, name, nationality, URL. These are your column names. This is your first record, this is your second record, this is your third record, and so on. So you can see you have huge amount of data, like all the details about the drivers. So there are like 214 drivers and his name and his nationality and its his URL. So this is considered as a one of the semi-structured JSON file. So these were the examples of structured, semi-structured, and unstructured data. These are form of data. Now the question comes, why big data? So, so there's a short history on why big data. So, like when it comes to big data, one of the most important aspect of big data is storage. So where to store this huge amount of data? Okay, so that cannot be stored in a single machine, or one that cannot be stored in one traditional machine. Suppose if I have my laptop and if I say that, okay, my storage is around 2 TB, 3 TB. Yeah, you can store till 2 TB, 3 TB. But what if I have a huge amount of data, like if I'm processing 5 TB, 10 TB of data, you cannot store that into one traditional machine or one single machine. So there was a biggest problem back then to store the data first, but where to store this huge amount of data or massive amount of data, that was the biggest question. Once you store it. Okay, the second problem was how to process it, because you have come up with a solution like, okay, I can store huge amount of data, but if you store it also, then how will you process that data? Because we need, in the final outcome is you need to process your data, you need to pull out something from your data. So that were the two biggest questions of big data, like storage and to process. And there was a scalability also, like to scale. Suppose I'll talk about scalable. Let me go back. So to store and to process the huge amount of data, like first we need to store the data. And to store the data, it is not possible to store in a traditional systems or a single machine. So the obvious answer for this question is, like, are traditional system fit to store huge amount of data? Obviously the answer is no. You cannot store huge amount of data into your traditional systems. So the problem, like to store, to process and to scale, was a distributed system. So let me explain you. uh, when you are talking about storage, specifically storage, if you are taking a traditional or a monolithic system, here if you consider only one machine, that is highly not possible to store huge amount of data in this. But rather than using a monolithic or a traditional system, you can go with the distributed system. So what does distributed system means? Like, instead of having one machine, if you have n number of machines with you, and you can call this as a master PC, and these are all your small pieces, or you can call them as a slave pieces, or you can call them as a worker nodes, slave 1 2 3 4 5 6. So instead of storing all that into one PC, okay, let me give one more example, a scenario based example. Suppose I have like 2 TB storage in my laptop, and I have I have a maybe 16 GB RAM, for example, 16 GB RAM. Let me take that color. Now I have built a, like a ecosystem to, or I've built a pipeline to handle 2 GB or 2 TB data. Okay, I have designed an ecosystem that will handle 2 TB of data. I have built the resources, everything is set now. And suppose, just in case, your data is now not 2 TB, it is 3 TB. Now you might think like, okay, I have to purchase again 1 TB extra. And if you try to purchase 1 TB extra, now you can handle 3 TB data. But think on what will happen to this RAM. So this RAM was capable of handling 2 TB, but if you are extending it for 1 TB or 2 TB extra, so you need to again think of RAM also. So that was like highly not possible to increase the storage in this manner in a monolithic system. So when it comes to distributed system, every machine has its own storage and every machine has its own RAM. So if you have like 3 TB of data, when it comes to distributed system, you can store 1 TB data in this machine, 1 TB data in this machine, 1 TB data in this machine. And similarly, the problem of scalability also got solved. If you are working on 3 TB data, I'm just giving an example. You can cancel out these machines, and you can only work with only 3 machines. So you can easily scale up and you can easily scale down. Now, suppose tomorrow if I'm working with only 2 TB of data, so you can easily cancel out this machine, and you can work with 2 TB of data. Suppose if there's a huge requirement in future, and if I'm working on maybe 5 TB or maybe 8 TB of data, and if I'm storing 1 TB in each machine, I can easily scale up, like just adding one or two machines for my from my master machine. So one and two. So I can easily scale up and I easily scale down. So this is all. I'm not talking about uh, computers in a physical manner. I'm not going to purchase like these small computers and I'll not going to connect all this to a master PC. I'm talking all these distributed system virtual. So with one single machine, I can virtually place multiple machines in one machine. So I'll be handling only one machine, but in that machine, I will be connecting all small or all slave machines with this virtually. Virtually, that is important. So if you go back and check, so we have come up with a solution like, okay, you can store huge amount of data, like we can store huge amount of data by distributed system, and with that distributed system your scalability problem also got solved. You can easily scale up, you can easily scale down. So that is the problem solved by storage and by scalability also. But now you might be thinking like, okay, if you are working on 2 TB, 3 TB of data, and if you are taking one single machine and virtually you have taken four machines and you are storing 500 MB in all, 500 MB, 500 MB in each, for example, and this comes around 2 TB of data. Now I have stored it, I can easily scale up and scale down. But the biggest question is, how shall I process this? Because the data is not sitting in single machine. It is sitting in some different nodes, some different machines. So how should I gather them together and how should I start working on them? Suppose if just imagine I have a data like this, a table like this, and there are suppose 10 rows in this. Just for example, it can be thousands of rows, lakhs of rows, but just a simple example. Now I want to do some aggregation on this. Like just now we have seen, like we have calculated sum, mean, max, some aggregation. I can easily perform the aggregation, but I'm doing some processing. But what if these two rows are in one first machine, in this machine, and next three rows are in the second machine, next four rows are in the fourth machine, next two rows are in the fourth machine. So how will you handle these all rows, because that all rows are sitting in different nodes? So how will you process? So that is the biggest question of big data. Complete this. So that was the biggest question, like how to process that distributed data. So we will be talking about that. So okay, so now when I talk about a virtual machines, like I have a single machine and I set up a distributed machines, and these are nothing but your virtual machines, or even this master or this main computer can be set up in a virtual also. We will talk all about that. So when you're talking about machines, actually they should have some resources. Okay, like if we want to set up a virtual machine also, like we need to set up like what could be the RAM of that, what could be the hard disk of that, what would be your like compute resources like CPU, core. I'm just giving an example. If you're talking about RAM, it is obviously memory. So example can be your 16 GB, 4 GB, 8 GB, 32 GB. Depending upon your workload, you can decide your RAM. So why I'm telling you now, because whenever I tell or whenever I call resources, so resources means these three things. So you need to be like you need to remember this. So when I tell resources, that means it will consist of memory, it will consist of storage, and it will consist of compute. So when we are setting up a virtual machines for our big data workload, so we have to set up the resources first. So depending on the workload, we will decide what memory and how much storage we need and which compute uh, process we are going to use. So that is about resources. Now, so I put a question like how to process that. Like there was a question obviously like how to store and then how to process. So there come up a solution called Hadoop. So if you ask me like what is Hadoop? So Hadoop is nothing but it is a framework to solve the big data problems. So we'll come back to this slide later on and we'll see what is mean by Hadoop and all those things. We'll see the definition. But if you just read out here, so Hadoop is one of the Apache's project. So Apache is a like non-profit organization. Just a minute. Yeah. So Apache Software Foundation is an American non-profit corporation to support number of open source projects. So if you talk about Apache, so it will support open source project, and there are more than 350 Apache projects, 350 plus Apache projects. In that, one of the project is your Hadoop. Okay, there are many big data frameworks which supports or which have support in Apache. Hadoop is there, Spark is there, Storm is there, and so on. Okay, we are going to talk of Hadoop now, and then we'll go on to see what is Spark. Okay, so if you look at the simple definition, like Hadoop is an open source framework from Apache, and it runs on the commodity hardware. So it is used to and process store, process, and analyze the big data. So we are talking about Hadoop is used to store the data. Hadoop is used to process the data. Once you process the data, obviously we can analyze that big data. So we have seen so many examples of big data. So this Hadoop is a framework that can be used to store that huge amount of data, and it is also used to process the data. Now the question is how Hadoop have come up with a solution to store it and to process it. So that we are going to see. So let us see the Hadoop evolution. Actually, when does the Hadoop started? What was the problem of big data? All those things that we'll understand it in a clear way. So actually, the problem for big data arose with Google. So in 2003, Google has released a research paper like how to store large data sets. They have like released a research paper and they named it as on distributed storage, and they named it as Google File Systems, that is GFS. So that paper got released with a name for GFS, and it was like the research was done on like how to use a distributed storage. Then in 2014 they have come up with another paper, and in that they have published like how to process this. So just remember these words, how to process, and here they have like how to store. So how to process the large data sets. So on processing, they have done the research and they named that research paper as MapReduce. MapReduce. So that was back then in 2003 and 2004. And so there were some like researchers or like one of the employees in who was working with Yahoo. The name was Doc Cutting and Mike, I guess. So they were the genius minds of Hadoop. So they took these two research papers, like in 2003 and 2004, what was published. In 2006, they have taken this research paper and started implementing it. So they have successfully implemented it. And after successful implementation, they have named your Google file system to Hadoop distributed file system. They have renamed from GFS to HDFS, that is Hadoop distributed file system. And the second research paper, if you remember, that was on MapReduce, that was on processing, that was not renamed actually. They kept MapReduce to MapReduce only. Okay. So this was the solution that uh, Doc Cutting and Mike researchers have come up with a solution for big data, like how to store by using HDFS and how to process by using MapReduce. So with this, they have launched Hadoop 1, Hadoop version 1. In that, they have introduced two core components. One is HDFS for distributed storage. Second is your MapReduce for distributed processing. They have come up with this solution. But they have, okay, let us see history here. Then in 2009, Hadoop came under Apache Software Foundation. So just now we talked about Apache Foundation, and it became an open source. Then in 2003, Hadoop has released its second version, and they have done major changes in their second release. So if you look at Hadoop 1, they were having a core components like only MapReduce and HDFS. But when they released Hadoop second version in 2013, they have come up with this second or third component inside their Hadoop core. That third component was nothing but YARN. So they had MapReduce for distributed, and they had, sorry, MapReduce for processing, they had HDFS for distributing, and they have introduced YARN also. Now, what is YARN? So YARN is nothing but it is used as a cluster manager. So if you remember, I talked about virtual machines or I talked about distributed system. So to connect those distributed system to your main system, we use YARN. So YARN is called as a resource manager. We will talk about that in detail, but the full form of YARN is nothing but yet another resource negotiator. So this is YARN. So YARN is mainly used and responsible for the resource manager. So I talked about resources. So what do you mean by resources? So what will be the work of YARN? We will be talking about that in detail in coming slides. So when I Yeah. So when you talk about this core Hadoop, so inside your Hadoop, there are three more like core components. One is MapReduce, second is YARN, your cluster manager, and your HDFS. So HDFS is used for distributed processing and to like for the cluster manager, we use YARN. So there was Hadoop core, everything was working fine. But if you want to do like different varieties of things in Hadoop, so you definitely need to learn Hadoop. Apart from that, you need to learn various tools. If you want to do, suppose 10 different things on Hadoop, obviously with big data, we do that. So you have to learn 10 different frameworks. For example, if you want to use your Hadoop with database, then we have to learn HBase. So Hadoop with HBase. If you want to write a SQL queries on this on top of this Hadoop, so we have to learn Hive. So to write a SQL queries. So HBase is used for database, Hive is used for writing a SQL queries, and this Whoosy is used for workflow scheduler. If you want to schedule your workflow, then we use Whoosy. And for scripting, if you want to use like scripting on top of this Hadoop, we need to learn a different framework called Hadoop and Pig. And when it comes to Scoop data exchanging, if you want to ingest the data, we need to know of Scoop. So a simple understanding, if there are, you need to do 10 different things, 10 different things on Hadoop, you need to know 10 different frameworks. You need to work on 10 different frameworks on top of Hadoop. Definitely you need to know Hadoop, Apart from Hadoop, you need to know each and everything. I have not talked more about Spark because this Spark is also built on top of Hadoop, but you can do everything on this Spark. You can like create a database using a Spark. You can use a SQL queries on top of that. You can use Spark as an ingesting tool. Everything can be done on this Spark. A lot more can be done on Spark. So we are going to see in detail in our coming videos like how uh, Spark is used.